Welcome back to the channel, and I am back at work at the rebuild of my South Bend steady rest. If you watched the first video in the series, you'll know that I'm missing all three of the adjusting knobs. I made this 3D printed prototype just to make sure that my design was going to work the way I wanted it to, and to see that it at least matches a little bit of what the original would have looked like. I have 3 pieces of stock that I cut on the bandsaw that are a little bit wider than the final dimension will be and a little bit taller. So let's get over to the lathe and start working this out. I struggled quite a bit on the order of operations to make these, on what I should machine first and second and so on. And I think we'll find out that the best approach is going to be to machine the inside features first and then machine the outside second. The first thing that I want to do then is to face off the ends so they're at least parallel with each other. The final length of this piece is going to be 2 inches, so I want to make sure that I leave myself some room when I do this next facing operation. So I'm just measuring here to make sure that it'll leave me plenty of room to get an accurate length. With the second side face, before I remove it from the lathe, I want to put some blue dicom around this end so it'll give me a spot to scribe them for the right height. This little YouTube channel of mine, which I started so I could show my friends and family some of the things I get myself involved in, has been growing steadily over the last year or so, and that's completely due to you, those that are subscribing and those that are liking and commenting on the videos. I really do appreciate it, and those likes, those comments, you subscribing really does help the channel grow and helps it get suggested to other people that might enjoy this content. So if you do like this video, please give it a thumbs up and leave a comment. Although I don't need it to be exactly 2 inches, I do want to get it to be as close as possible for that. So I'm setting them up on my granite surface plate and using a height gauge with a carbide scribe on it. I'll set the height gauge to 2 inches, and then I will scribe a line around the circumference of the stock where the blue dicom was placed. This will give me a visual indicator of how far to machine the length. So I can load these pieces now back up in the lathe and finishing to length and then finish out the interior features. I'll use a parallel on the flat here just to give the bottom of it something flat to sit against, and hopefully that will give me a better chance of this thing being squared to the chuck. The next step here is for me to face this piece off until I get to my scribe mark, and that'll be good enough. This dimension isn't overly critical. As I normally would do, I'm going to use a centering drill to spot the face, and then I'm going to drill a 1/4 inch pilot hole through the entire part. I replaced the pilot drill now with a 3/4 inch reduced shank drill bit. This will be the start of the hole that I need to bore in this end to about 1 inch and 350 thousandths deep. I do want to slow the lathe down a bit here. That's a bit fast, I think, for this size of a drill bit. I think that's a much better speed. I put a line with a paint pen on the drill bit that will give me a guide as to how deep I want to go. I'm going to slow the lathe down a little bit more here, put it in its slowest speed without going into back gear for the next size bit, which will be 15/16 of an inch. And since I really don't need the lead screw moving for this, I'm not going to be doing any power feeding. Take that out of gear and it'll at least be a little quieter in here. I'll enlarge this hole a little bit more here with this 15/16 inch drill bit up to that same uh, depth as we did before, as I indicate here with this line I used a paint pen to make. I've got the boring bar mounted on the tool post now. I need to bore this hole to a depth of 1 inch and 350 thousandths. So I want to make sure that there's no more tool stick out than there needs to be. With the lathe off, I touch off the boring bar to the front of the piece. I want to set a 0 on a dial indicator so I can judge that 1 inch 350 thousandths depth. Unfortunately, my longest travel dial indicator is this 1 inch indicator, so I have to set it and move it a few times in order to get that full distance. So when it lands on 0, I'll know when to stop the power feed. So this piece is going to be threaded internally with a 1 1/8 12 TPI thread. So I need to bore this out to a diameter of about 1 inch and 35 thousandths. That should be the minor pitch diameter, or approximately the minor pitch diameter for this particular thread. Now the drilling operations left a cone-shaped end on this, so when I get near that depth, I want to back this boring bar off a bit and try to flatten out that inside recess. The depth of this bore isn't a critical dimension. I do want to get close to that target, so I'm just going to use a scale to judge how that's going. Now that we've taken a couple of light passes, I'll use my telescoping bore gauge and a 0 to 1 inch micrometer to check the diameter and see how far I still have to go. Still have a way to go here, so we'll go back at it with the boring bar until we get to that minor pitch diameter. I'm only going to be threading the first 1 inch of this bore, so the remaining 350 thousandths I want to bore out a little further in order to create some thread relief. I'm setting up this dial indicator I have clamped to the bedway to give me a travel for that 350 thousandths, so I know when I need to stop going in, and also when I back the carriage out where I need to stop coming out. I don't want to damage that area that's going to be threaded. I have this shop-made tool. It looks like it was part of a carbide end mill. I acquired this in an auction lot somewhere, I'm sure. I don't remember exactly where, but it is ground exactly the way that I would need it in order to cut this last little bit of thread relief. I'm going to be feeding this completely by hand, and because of the shape of the cutting tool as well as the way this interior of this bore is, I'm going to have some chatter at the extreme left or extreme right of the tool travel. I'm okay with that. It might be causing some strange surface finish on the inside, but that's not going to matter. I just really need this for thread relief. Well, with the bore cut to size and proper shape, I can now pull the boring bar off and get ready to be set up for threading. And just like when I was cutting external left-handed threads, when cutting internal right-handed threads, you want to bring the compound around to the opposite side of 0 at 29.5 degrees. This is done so that as you use the compound to advance the cutting tool into the material, the thread is being cut more so on the forward edge of that cutting tool rather than both sides of it. The theory is that this reduces tool pressure and results in a better finish on the thread. Now, I couldn't tell you if that's true or not. I'm just going to go with the flow and do what everybody else is doing. And since I have turned the compound onto the other end, I needed to loosen the tool post, and I want to get it realigned to be square with the chuck. One of these days I need to collect some additional boring facing tool holders for this BXA tool post. I only have one that I can use here between the boring bar and the internal threading tool. It just so happens that the diameter of my boring bar is the same diameter as my internal threading tool, so the tool height doesn't need to be changed here at all. Before I can do any actual threading, I'm going to put a little bit of blue dicum on the inside of the bore. I'm going to touch off with the threading insert, and the blue dye will make it a lot easier for me to see when it actually makes contact. And I'm setting my compound and my cross slide to 0. These will be my baselines that I'll be able to return to if I want to come back to the starting point. I have the gearbox set for 12 threads per inch. Now I'm going to go ahead and make a scratch pass to just validate that. Everything looks good there, so I can set the dial indicator I have on the back of the tool post to 0. This will let me know exactly how far I've engaged the thread cutter into the material. I'll start with a 5 thou depth of cut. According to the math, my target will be somewhere between 45 and 50 thou deep. After a couple of spring passes at 40 thou depth of cut, I will then do a test here with the knob sleeve just to see how close I'm getting. I'm pretty close here. I probably only need to take off maybe another 1 or 2 thousandths, and I should be right where I want to be. Well, at about 49 thou depth of cut, I'd say the math was pretty spot on. That's a perfect fit. It threads in there really nice. It's not too tight and it's not too loose. The next step is to drill out that center hole for that 7/16 inch drill rod that we use to make the left-handed adjustment screws. So I'm starting here with a 27/64 drill bit. And follow up the drill operation with a reamer. This is actually my first time ever using a chucking reamer. It's a 7/16 inch reamer that should take the hole to final size. Do a quick test fit with the adjustment screw just to make sure that the label on the reamer was correct, and it fits perfectly, exactly how I expected it to. So far, I'm really happy with this. Now I just need to make 2 more. Well, that finishes the interior features on all 3 of these pieces. I'm pretty happy with the way that they came out. The internal threading went a lot smoother than I predicted, to be honest. The adjustment sleeves thread in really smoothly, and the adjustment screws fit into that reamed hole perfectly. I must have contemplated a dozen different order of operations on how I wanted to machine these parts. I had originally thought I was going to do all the outside machining first and then do all the inside machining second, holding it by the thinner diameter of the adjustment knob. But I felt that that was going to require some tail support, which kind of defeated the purpose of doing all that anyway. So So I think my next step here in the way that I landed was to turn this piece of stock into a threaded arbor. That should give me plenty of support and also give me access to all of the external areas at once to machine all of the features. But that's going to have to wait until next time. So thanks for watching. Be sure to subscribe so you can see how this thing turns out.